basically this will be an introductory webinar. We will be introducing a few topics on system design like caching, load balancing, database sharding, and all that.
Welcome everyone. Hope you're keeping well and staying safe. This is Hafsanjum and I am working as a community executive at Recro, wherein we are working towards building an exclusive community for developers to help you get connected with like-minded people, build your network, and grow professionally. So those who don't know about what Recro is, it is a developer-focused platform helping developers to meet the right opportunity by connecting them with fast-growing startups such as CureFit, Udan, Swiggy, Dunzo, etc. So welcome to Recro Talks again, and today we are doing a webinar on system design interviews for backend. Our guest speaker for today is Saurabh Prateek. Saurabh is working as a web solution engineer at Google. He is more inclined towards programming, system design, distributed systems, data structure, and algorithms. Saurabh also owns his newsletter of system design with over 5,500 subscribers. Thank you so much, Saurabh, for joining us. You may go ahead and say hi to the audience.
Yeah, sure. Thank you for having me. So hi, my name is Saurav. As she introduced, I'm working as a web solutions engineer currently at Google Gurgaon, and we have planned a nice webinar for you all on system design backend. So basically this will be an introductory webinar. We will be introducing a few topics on system design like caching, load balancing, database sharding. It will be good if we have some communication, like if people are joining and if I ask some questions, you can write and reply it on the chat as well. And if you have any doubt, we will take it up probably. Okay, so this is basically intro to system design. So I won't be discussing much in depth. We will be probably focusing on the basic concepts and how we can use this. So let's start with what is system design. So according to Wikipedia, system design is the process of defining the architecture, product design, modules, interfaces, and data system to satisfy specified requirements. So this sounds a little complex. So in basic, what happens is that in system design, what we are given a particular system with some features which we need to implement in that. And what we need to do is that we need to build that system so that they can deliver all the features which we have decided. Now, what we need to take care is the load. Like first, we need to know that what load our system need to handle. And according to that, we need to design it. So if the system is handling a very huge amount of load, then we need to introduce some advanced concepts, need to think a lot about it, that how do we scale the systems and all. But if we are building a very basic systems with handy clients, client requests and all, then probably a basic system can work. So the agenda of this presentation will be, we will be starting from a very basic system. Initially, the system will be handling very few client requests, and progressively we will increase the client's request, and we will will basically scale our system, introduce some concepts and all. So this is the basic agenda. So in order to introduce you with the concepts, so that where they are used, you can understand where these concepts are used, where should we apply this, and how do they help in scaling the system. Any doubt till now? Anything? The agenda is clear, right? Okay, good. Sure. Atif says yes. Okay, nice. Nice. Okay. So the first thing is that let's design a naive system. So what we're gonna do is that, suppose we will assume that we have a system and we have some incoming client's request, and what our system will be doing is that it will be taking the client request and will be returning a response after some processing and computation. Like it will take the client request, it will do some processing. If it requires the data from the database, it will fetch the data from the database and process the response, and it will finally return it to the client. So what's currently happening is that initially our system is handling very less clients requests. So it's about 10 to 20 clients requests coming up per day. So we don't need to think much about scaling. So what should we do currently? Like how should our architecture look like? So if we see in the next slide, um, so basically our architecture can look somewhat like this. It's a very naive architecture, I know. We have two components only. One is the application server, where the business logic resides, and another is the database server, where obviously the data resides. How many requests a single Spring Boot application handle? Okay, so currently, Gaurav, we are um, focusing on 10 to 20 clients requests. We will be scaling it as we move ahead with the presentation. Yeah. So what happens is that what happening here is the architecture is taking some clients requests. It is the clients are sending its request to the application server, and then application server is communicating with the database server, and after that it is processing the response and it is returning it to the client. Okay, yeah. Does the programming language you choose for backend a very big factor? Or Kofi, okay. Akor asks, like, does the programming language you choose for backend a very big factor? I don't think so. And in this presentation, we won't be discussing about the programming language since it's an HLD topic, not an LLD one. So we will be looking it through at a high level, basically. So for this, the programming language doesn't matter actually. Okay, let's move ahead. Okay, so what are the drawbacks of this architecture? Like, this is a very naive architecture, so it should be having some drawbacks, right? Um, so one of the major drawback is the single point of failure. As you can see that here we have only one application server, and here also we have only one database server. So what can happen is that since it's a hardware, it can fail, right? So what if the application server fails? Since we have a single application server, if this application server goes down or it fails, then the entire system halts because there is no other replica to take its place and does its work, right? Another thing, the same goes with the database server as well. Like if the database server goes down, the entire system can basically get halt and it will not able to return the response. So one major disadvantage is the single point of failure. Another is that it cannot scale for large number of users, right? So what will happen if a large number of clients start sending their request to this application server? So one thing it might happen is that the application server, first thing is that application server won't be able to handle such large requests. So what can happen is that they can have a queue with them, a request queue where they can store the upcoming requests. So suppose application server is handling one request and another client sends another request at the same time. So what can happen is that they can have a queue and they can save that request or they can push that request into the queue so that once the application server is done with that request, it can pick up another request from the queue. So what will happen? So in that case, there will be a lot of wait time introduced here. Like the client will need to wait for the application server to get done with one request and then it will handle their request. So there will be a lot of time, like a single request can take a lot of time to get processed. So first thing will be is the response time will be huge. There can be throttling as well on the server, on the application server and the database server, since they are getting a lot of requests at one time. So these are the two major disadvantage that this architecture has. And yeah, so the single point of failure and the chance of crashing and a high response time. So these three are the major disadvantage of this architecture. Now, what shall we do if we need to scale this one? Like this is a very naive architecture and we are planning to scale this. So what shall we do now? Okay, so let's scale this architecture. Suppose now your system gets famous and everybody knows about your system. Now what will happen is that everyone might come to the system, they start sending requests and your system will start accepting a large and large amount of requests. So suppose your system start accepting tens or thousands of clients requests per hour. Now this is the big number, and for this, this architecture will not work. So we need to introduce some scaling. Like we need to scale this architecture actually. So what we can do is that um, we can either go with a horizontal scaling or a vertical scaling. So first, let's understand what does this concept means. Like what is a horizontal and what is a vertical scaling. So first, horizontal scaling. So what happens in horizontal scaling is that we have currently in our architecture we have a single database server and a single application server, right? So what we will do is that we will introduce more application server, like more machine of same configuration to our system, so that the requests should be distributed. So now what will happen is that earlier only one application server were handling the request. Now three or four application server will handle the incoming load. So the load will get distributed. So suppose there are four requests or five requests can be handled at the same time by multiple servers. So that is one thing with the horizontal scaling. Another good thing with horizontal scaling is that it scales really well, because actually horizontal scaling doesn't have any limit, because you can introduce n number of application server in your system and there is no limitation. You need to be sure about how to distribute the load and you will be good with that. For horizontal scaling, you need to take care of two things. One thing is that now, since you have multiple application servers or machines introduced in your system, there will be network calls. There will be RPC calls, remote procedure calls, or API calls, because in order to so that two servers can communicate. Because now, since there are different machines and there can be a chance that they are placed at different geographical locations. So one thing is that there will be RPC calls, network procedure calls, and another thing is that you need to have a load balancer, because now what's happening is that there are more than one application server. So client should know that to which application server they should send their request to. So in that case, now load balancer comes into picture. What load balancer does is that it distributes the request to those servers. So we will discuss about it in the next slide. This is horizontal scaling. Next, we will discuss about vertical scaling. So what happens in vertical scaling is that we don't introduce more machines in our system. Instead of that, we increase the computation power or computation capacity of the existing machine. So what we can do is that we can increase the RAM, increase the memory, increase the storage capacity, increase the cores of the processors of a single machine so that it can handle more requests. But vertical scaling, one thing with the vertical scaling is that it's hard to scale. Hard to scale because every machine has a capacity, right? You can't increase the computation beyond a certain limit. Like there is a limit on that, and that's why vertical scaling is not preferred much. If you are dealing with huge amount of load, there is a chance that your system can fail. Another disadvantage is that you have introduced a single point of failure. Even though you have a single machine, you have increased its computation capacity at a high extent, but still it's a machine, it's a hardware, right? So it can fail. Like if someone can accidentally plug off the um, like remove its plug, or there can be some hardware failure, ROM failure, anything that has happened due to which that system stops working. So in that case, your entire system will get halt, basically, because you are dependent on that machine, on that single machine which you have vertically scaled. Okay, one question. Gaurav Singh said, I didn't understand network calls. Please explain once. Okay, Gaurav, actually in horizontal scaling, we have multiple application server. So what can happen is that one server is at one place, another server is at another place, and they are located at different places, or they are different. They are separated. So what we need to do is that we perform an RPC call or network calls in order to, so that they both can interact with each other. If we have a single system, then you perform method calls, right? You simply perform method calls or function calls, and that is very fast. They don't need a network or RPC call because the entire code resides in a single system. So that's why vertical scaling is a bit fast, because you don't need to deal with all networks and all like network calls and RPC calls. But in horizontal scaling, you need to deal with the network calls or the RPC calls. So what shall we do here? Like in our architecture, like we have discussed horizontal scaling and vertical scaling. What should we pick? Okay. Yeah, what should we pick? So I think we will go ahead with horizontal scaling here. Like let's go ahead with horizontal scaling, because as we discussed that for our system, we don't know the amount of load we are getting, like we are expecting. So vertical scaling might fail. So let's go ahead with horizontal scaling. What we will do is that we will introduce more application server in our system so that it can scale ahead. Okay, so now we have introduced horizontal scaling here, and this is our updated architecture. So what is happening is that we have introduced more application server so that it can handle the increasing load. Okay. Now still there this architecture has some drawbacks, and one drawback here is the problem of uneven load distribution. As I said, that clients don't know, like clients doesn't know that which application server they should send their request to. So suppose earlier the clients were sending their request to this application server. So what will happen is that currently also they don't know that we have introduced an application server in our system. So suppose they all send their request to a single application server. Again, what will happen is that that application server can uh, basically wear off or get halt or something. So it can
As part
basically
of
fail.
this,
Yeah,
we
yeah.
also have questions waiting in the Q&A tab
Okay,
along
okay,
with the
sure,
chat. Yeah.
sure.
So guys, please post your questions to the Q&A tab so it does not mix up with the normal chats. If you're having something really insightful to ask, please do post it in the Q&A tab so that we don't miss on it. Posting in the chat is something really um, cluttered up, and we might miss your questions if you post it on the chat. Please do make sure of the Q&A tab and post it right there.
Okay, sure. And I guess we have two interesting questions on chat. Like Gaurav says that I'll take up two questions very quickly. Gaurav says, does the choice of SQL, NoSQL DB affect the scaling? Actually, Gaurav, it depends upon the data which you have, the structure of the data. Like if you have very unstructured data, then you can go with a NoSQL database. But if you have a very structured data, tabular representation, then it's okay to go with the SQL database. Both can be scaled. Like it's not that only NoSQL database scale. There are few applications which scales on SQL database as well. I guess Stack Overflow uses SQL database. I guess YouTube also uses SQL databases. So it depends upon your data and your use case only. Both can scale. And another question is that in this scenario, we scaled application server. Yeah, I understand that we have only scaled the application server. We have still yet to scale the database server because you can see that the load is still going on a database server. Like it's a single one. So yeah, a good question. We will gonna scale that in future as well in the next slide. Okay. Okay. So yeah. So this was the problem of load distribution. Like the client doesn't know, and they can send all their requests to the application server. So we need some component which can take all the requests of the client and it can distribute it evenly to the application servers. And here load balancer comes. So what load balancer does is that since we have a multiple application server, we need something to distribute the incoming client request. So what will happen is that load balancer will stand between the application server and the clients. And what client will do is that now clients won't send their request directly to the application server. Instead, they will send their request to the load balancers. So actually the request will be routed to the load balancer, and then the load balancer will itself gonna route the request further to the application servers. Since we have a lot of application servers, so load balancer will keep it in mind that how to distribute the requests evenly to the application servers. So this is the main motto of the load balancer. Another one thing a load balancer can also does is that it can also perform some health checks on the application server. So suppose if one of the application server fails, then load balancer might get to know that this application server has failed and I don't need to send any requests further to this application server until it gets back to the system healthy. So another thing is that load balancer can also perform some health checks of the application server. Okay, and let's add the load balancer. So this is our updated architecture now. We have a load balancer which is between the client and the application server. So as you can see, the clients are sending their request to the load balancer, and then load balancer is further routing those requests to the application servers. So in this way, it is making sure that the requests are distributed. There are no hotspots. There are It's not like 70% or 80% of the traffic is being directed to one application server while other application server sits idle. So it makes sure that the computation power is distributed, like every application server is performing at its peak. So okay, types of load balancers. So since we are talking about load balancer, we should also talk about two types of load balancer, basically L4 and L7. So L4 load balancer is also known as layer 4 load balancer. And it is, I think it is taken from the OSI model. The L4 is the layer 4 of the OSI model, which is, I guess, the transport layer. So what it does is that it takes a few packets from the TCP stream, and on the basis of that address information, it routes the requests to the application server. Another is the L7 load balancer. It is taken from the seventh layer of the OSI model, which is, I guess, the application layer. So it decides the routing on the basis of the content of the packet or the application content. So one example can be that it can decide on the basis of the what kind of request does the request is based on, basically. So if the request is based on images, then it can send it to one application server. If the request deals with videos, then it can send it to another application server. If the request is basic text, simple text based, then it can send it to another load balance, another application server. So these two are a major load balancers, types of load balancers, which we can discuss here. And yeah. So another question, like this question has been asked before. Now we have designed our system. This was the current updated architecture, but if we see carefully, we can see that still there is a huge load on the database server. We haven't scaled our database server. We have scaled our application server, but the database server is still left to be scaled. So what can happen is that still there will be an increasing load on the database server. And there can be a chance that the database servers can get halt or can fail, right? And if the database server fails, then our entire system will go halt because it's a single point of failure. There is only one database server here. And if that goes down, then we won't be able to process any request from the clients anymore. So how to scale that one? Okay, what we will do is that we can cache our requests. So what we can do is that every application server contacts to the database server if they need it, right? So suppose a request comes to the application server and they are contacting some data to the database server, then what they can do is that they can store that data in a cache and can return the response, so that if the data is required again, then it don't need to send the request again to the database server. It can basically retrieve it from cache, and retrieving the data from cache is much faster as compared to retrieving it from disk, because cache stores the data in RAM, uh, in the temporary memory, which can be accessed very fast as compared to the disk storage and databases. So that's the basic concept of caching. What we can do is we can achieve two things here. The API response time can also be reduced because caching is fast. And another thing is that the load on our database server can be reduced to a certain point. We can, yeah. So in caching, there are two basic things: cache hit and a cache miss. So when we are looking for a data in a cache and we are not able to get that data in a cache, or suppose that data is absent in the cache, then we call it a cache miss. And then what we do is that we go ahead and go hit the database and demand the data from that. Another term is cache hit. So suppose we are looking for a data in the cache and we ideally found that, then it's called a cache hit. In that case, we simply fetch the value from the cache and return it to the user or a client. So why caching? As we discussed, caching is fast. One thing, because it is stored in the temporary memory and can be accessed very fast as compared to the disk storage and all. And another thing is that less database calls, because if the data is present in the cache, then we don't need to look up in the database. Another thing is reduced computation. So what does this mean? So suppose um, we are getting a request and we need to perform some computation, some calculations and processing, which takes some time, and then we are getting a particular data, and then we are sending that data to the user. Then what we can do is that instead of performing same computation multiple times, what we can do is that we can get the request, perform that huge computation once, and store that result in the cache, so that if that request comes again, we don't need to perform that computation again. We can simply take the data from the cache and return it to the user. So this will reduce the computation, reduce the uh, memory which is taken by the computation, which is taken by the server. So it reduces all the things and we can simply return the data from the cache. Okay, and one thing which we need to worry about is that there can be some data inconsistency if we don't handle the data, the caching layer uh, well. So what's happening here is that now our data is present in the cache as well as in the databases. So there are two places where we are keeping the same copy of data. So what can happen sometime is that the data in the database, the same data, the same copy of the database can get updated in the database, while that copy is left updated in the cache. So what we can see is that the same copy will have different values, like same keys in the cache will have different values, and that is indeed a issue of data inconsistency. Like we don't know that which data is real or on which data should we rely. So we need to take things seriously when we are using cache. And this is a simple algorithm. What happens when we read from a cache? So basically, when we see a cache, we can see that a cache is a basic map. It stores data in a key value pair. As we have heard about a hash map or some kind of data structures like that, it stores the data in a key value pair. So we demand a value from a key. So what we do is that we have a key, we look up in the cache with that key, and if that key is present, then the cache returns us the value, and we get the value and we return it. And so this is ideally what happens in the read functionality. So what we are doing is that we are taking the key and we are asking the cache to get us the value for that key. If the cache returns the value, then we will return that. If the value is not returned, then the value will be nil. So if the value is not present in the cache, then what we will do is that we will go ahead and fetch that value from the database. So now what we are doing is that since we didn't get that from the cache, we are fetching it from the database, and that value is returned from the database, and then we are storing that data in the cache, and then we are further returning the value. Why that? Because it was earlier absent in the cache, right? So now we fetched it from the database. We ideally put that in the cache so that if we are demanding the same value for the same key, we don't need to look up ahead in the database again. We will get that from the cache next time because we have stored it in the cache here. Now what will happen is that if we read that key again, then the cache will probably get us the value and we will return it. It won't go into this if branch. Another, yeah. And writing to the cache. So we discussed about reading from the cache. Right now, what about writing? So in writing, what we do is that we simply have a key value pair. We write it to the database in order to uh, reduce data inconsistency. What we do is that we write the data directly into the database and we delete it from the cache. So what will happen is that the older value, if the old value is present in the cache, that will be deleted by the key, and the new value is updated in the database. So what will happen is that next time when we read that updated value, we won't find it in the cache, and we will fetch in the database and we will put the updated value in the cache and we will return it. So in this way, if the data is updated, we won't get the older value from the cache or the previous value or the stale value from the cache. We will always get the updated value. So that is the idea about the cache. That is how a basic algorithm works of reading and writing to the cache. Now let's look at the updated architecture. So now we have introduced a caching layer between the application server and the database server. So now what will happen is that every application server has a cache associated with that. So what will happen is that the application server will contact the cache layer, and then if the cache is not present, then if the data is not present in the cache, then it will further contact the database server. So it will reduce the load at to some extent on the database server, but still it's not good. Like still we have some load on the database server, but yeah, caching layer will reduce some amount of load on the database server because it will cache the data. And ideally, cache use some policy to store the data. So basically they use an LRU format, so least recently used. So what they does is that those keys which are, since the cache has a limited storage, right, it can't store a lot of values. So what happens is that the keys which are used very less frequently, they are pushed down, and once the storage exceeds or once the key limit exceeds, those keys which are used very less frequently are evicted from the cache. So basically they are removed from the cache, and those keys which are very hot or which are used very frequently are always kept at the top. So this is a very interesting algorithm. You can also look at it. I guess it can be implemented with a combination of hash map and linked list or something. Uh, so it's a very interesting algorithm. You can have a look at it, how the LRU works and how it maintains the hot keys or the most used keys at the top of the cache. Yeah, and another thing is that maintaining the states in our system. So according to this architecture, what is happening is that the client is sending the data to the load balancer, and the load balancer is sending the request to the application server. So what can happen is that suppose client C1 is there, and C1 sends its request to the load balancer, and then load balancer further routes that request to the application server 1. Now what will happen is that it will perform some computation, and it will have the cache stored associated with client 1. So whatever the data for client 1 is, that suppose it stores it in the cache, and then it returns the data response to the client 1. Now what happens is that a client 1 again comes again sends its request to the load balancer, and what happens is that this time, instead of sending it to application server 1, the load balancer sends the request to application server 2. So now what happens is that application server 2 can also perform the same computation, but we see here that the cache is already maintained by application server 1. So what will happen is that the cache which is maintained by application server 1 is getting unused. Like there is it is not used again because the same request is getting routed to different application server. And another thing what is happening is that now the cache layer of application server 2 will not have the data of client C1. And what will happen is that it will hit the database server. So what we could have done is that instead, if the load balancer would have known that the client 1 has came previously and it has been routed to the application server 1, so I should ideally route it again to application server 1 only, instead of routing it to a different application server. So if the load balancer had done that, what would have happened is the caching layer would have the cache present in the data present in the cache would have been reused, one thing. And another thing is that the load on the database server would have been reduced. Like the application server then won't require to hit the database, because it will get the data from the cache because the client one has came before. So this is the concept of statefulness. Like load balancer should remember that to which application server it should send the client to. Like the load balancers should ideally send one request to the same application server multiple times. Like if the same request is coming 3 times, then it should all the 3 times it should send those requests to the same application server, so that their states which is maintained by the application server can be reused again and again. And how does a load balancer can achieve the statefulness? So I will discuss about one possible ways in which a load balancer can achieve statefulness. So one possible ways is through the memorizing the IP address. So since every client which is sending its request has its IP address, right? So if a client sends the request multiple times, its IP address won't change unless they are using VPN or something. Their IP address won't change. The IP address will be the same. So by this, load balancer can know that if that request has the same IP address, the load balancer will know that it is the same client. So now what we can do is that we can perform some hashing. Like we can have a constant hash function. By constant, which means that hash function shouldn't change. We'll have a constant hash function, and what we're gonna do is that it will gonna hash the IP address, and it will convert it into a hashed number. The IP address will be converted to a hash number, and after that it will gonna perform some processing on that with the total number of available backend servers, and it will get the server ID to which it should route the request to. And how it does that is this is the simple way that a load balancer can achieve statefulness. So what is happening here is that client is sending the requests along with its IP address, and there is a constant hash function which converts its IP address to a hash based number. And this hash based number is then it's then modulo with m, where m is the number of backend servers. So why are we performing a modulo with m? It is because suppose you have there is every server has an index, and you have m number of application servers present. So you have indexed them from 0 to m minus 1. Like this is s0, this is s1, this is s2, and this is sm minus 1, right? So when you modulo a particular hash based request with M, you are making sure that the index is in the range of 0 to M minus 1 so that you can easily route it to a particular server. And since the hash function which we are using is constant, for a same IP address, it will always generate a same hash number, and that same hash number will be routed to same server. So even if a same client hits a request multiple times, the load balancer will know that the request is coming from this client. It is the one which has previously sent the request, and it will gonna route it to the same server, even if it hits the request 2 times, 3 times, or 4 times. And this will help in maintain the states which are maintained by the application server will now get reused, and probably the cache will be used more effectively, and the load on the database server will decrease to some extent, right? So this is the concept of how a load balancer, a typical load balancer, can achieve statefulness when we are dealing with distributed systems, like when we are dealing with multiple application servers. Okay, so another problem is the problem of server failures. So if you see this algorithm clearly, you know that we can see that it is performing modulo with M, which is the number of backend servers. If in future the number of backend server changes even by a factor of 1 or 2, the entire algorithm changes. The entire distribution of the request changes. Now what can happen is that all the cache which is associated with the application server, all the states which the application server has maintained till now, everything will be just will get useless, will be of no use. And what will happen is that the load on the database server will increase. So this is one major drawback which we have here, is that we can't handle, since there are a lot of application server, there is a chance that some of the application server can go down and this M number can decrease. So even if one of the server goes down, the entire distribution of the request will change. So this is one drawback of this current algorithm which we are looking at. And now what we can do is that here consistent hashing comes into play. So what consistent hashing does is that consistent hashing makes sure that even if 1 or 2 server fails, there is a very low change in the distribution of the request. So what it does is that if suppose S1 fails, then what will happen is that the requests which were earlier sent to S1, only those requests will be routed to a different server. Other requests won't be affected. Other requests will be in the same way. Other requests, like if some requests were be sent to S2 or some requests were sent to S3 earlier, they will be sent to S2 and S3 now, even now. So the distribution, there is a very less change in the distribution when we implement consistent hashing here instead of this algorithm. So this is the one major need of consistent hashing here. And I won't go in much depth of consistent hashing, but we can have a look at why consistent hashing is needed. So this is the basic need of consistent hashing, because since the number of application servers can change. So if we implement consistent hashing here instead of this algorithm, then the statefulness will be maintained to some extent in our architecture. Okay, and let's move ahead. Let's talk about the database server. So the current architecture looks like this. We have introduced a caching layer, we have introduced a load balancer, we have horizontally scaled our application server, but still database server is left. And since the database server is still left to be scaled, now we need to do something about the database server, because it's only one server. If it fails in future, the entire system will get hot, and we can't let this happen. So, and if the data in our database increases, then we can basically shard our database, or we can have multiple database server which can hold data. So the load on the database server, since we have a single database server, what we will do is that we will perform database sharding here. What happens in the database sharding is that we divide the data into multiple shards, and we store each shard in a different machine. So now we will have, instead of having one database server, we will have multiple database server. We can have 3 database, 4, or even more database server, and every database server will store a shard. And now what we'll have is that we will have a distributed database server. So a lot of database servers, and every database server is having a shard. So how to perform database server? There are two ways in which we can perform a database sharding. One way is horizontal sharding. So what happens in horizontal sharding is that we partition the data horizontally. So what we do is that, suppose if we have one table which is very large, like it has a lot of rows. Suppose we have one user table and we have a million of users. So what we can do is that we can divide that table row wise. So we can have 100,000 data in one shard, another 100,000 set of users in another shard, another 100,000 sets of users in another shard. So what it does is that it doesn't destroy the structure of the table. It only divides the table row wise. So every shard will hold the same structure of the table. Only the thing is that every shard will hold different data. So we can have a partition key, like this shard holds data from a range, key range from R1 to R2. This shard can hold a range from R2 to R3. And in that case, we also need to introduce some logic in our application server, so that application server can know that which shard it should hit. So suppose if the application server wants a data which is in the range of R2 and R3, then it should know that it should hit shard number 2, because shard number 2 is responsible for having the data in the range of R2 and R3. This is horizontal sharding. Another thing is vertical sharding. So what happens in vertical sharding is that instead of dividing data horizontally, we divide data vertically. And here we basically every shard can have a different structure of the table. So if suppose if your table has a huge amount of columns, or if you want to divide your table column wise, then what you can do is that you can do that as well. Or if you have a lot of tables in your databases, then what you can do is that you can place one table in one shard, another table in another shard. So suppose user table can um, stay in shard one. If you have another media table can stay in shard two. And if you have another table, so you can put that in different shards. So this is what vertical sharding does. Here what we will in our architecture, what we will do is that we will go with horizontal sharding. So what we will do is that we will have a single, suppose that we have a single table, we will gonna divide it horizontally, so that every shard will have same structure of the table, but the data will be different. Yeah, so since we are adopting horizontal sharding, we will have different shards will have different data, but the table will be structure will be same. So this is how now the updated architecture look like. Now we have done is that we have performed sharding on our database server. And since we have performed horizontal sharding, there will be a key range which will decide that what data is present. So uh, we can see that in this database server, it holds the data in the key range from R1 to R2. This holds from R2 to R3, and this holds from R3 to R4, and so on. So what will happen is that if the application server wants a data which is in the range of R2 to R3, so it will know, it will need to have, so we need to implement some logic so that it knows it needs to hit this database server, that server 2, to get the data. And database sharding is not always beneficial. There are some serious drawbacks of database sharding as well. One major drawback is that suppose we need to perform joins. In SQL, we used to perform joins, right? So suppose we need to perform joins, and what is happening is that we need to get data from multiple shards. So suppose we are getting 20,000 data, and we are getting 10,000 data from shard 1 and 10,000 data from shard 2. So what will happen is that we need to extract the data from both the shards, and then we need to further join those data, combine those data again in order to return to the application server. So there is some extra logic which is introduced, some extra work which we need to do in order to maintain these database servers. Another major disadvantage is that since we have a lot of database servers and we need to manage each and every one of them, if one of the database server gets down, then certain amount of data will be unavailable to us. So suppose if the database server 1 is down, then all the data which is present in the range, in the key range of R1 to R2 will be unavailable to the system. Still, our system entirely won't go halt, but yeah, a certain amount of data will not be available to the database server. Another thing in database sharding is that sometimes it happens is that some data becomes very hot. Like suppose there is some sale going on and everyone is trying to buy a particular, suppose there is a new model of iPhone launched, so entire entire every people is trying to buy that iPhone, and suppose the data of that is present in one of the database server. So what can happen is that there can be a chance that 80% of the traffic or even 90% of the traffic is directed to one of the shard. And what this is called hotspot in sharding. So it's basically the process of direction of uh, a major traffic to one shard. So that shard is known as hotspot, and the entire process is considered as hotspot in sharding. So what will happen in that case is that suppose the 80% of the traffic is directed to shard 2, then shard 2 will be the hotspot and it will have an increasing load, and there might be a chance that that shard might fail or that shard might go unavailable for some time and our system can get halt. So hotspot in sharding is one major drawback. And how we can solve the hotspots? So it's very easy to solve hotspots in sharding. We can simply cache that data which is in demand. If that data is not being updated very frequently, then it's good idea to store that data in cache for some time, till it is hot, till it is in very huge demand. We can put that in the caching, and we can the load on the database server can be reduced. Now what will happen is that the request will come and it will be returned from cache only. It won't need to go into the database server. So one way is to, if the data is not changing frequently, then one solution is to put the data in the cache, and we can get rid of construction of hotspots in the database servers. Another thing is that again it is difficult to add or remove database server, because you know that if we need to add another database server, then we need to again change the entire partition. Like all the data present in the database server will change, because it need to distribute the we need to distribute data random evenly, right? So a key range of all the database server will change, and we need to let the application server know that now this data is not no longer present in shard 1, it is now present in shard 2. Some new data has been introduced and it is present in shard 5, and so on. So adding and removing of database server can be pain in database sharding basically. So yeah, these are a few drawbacks which we should keep in mind while we are introducing database sharding in our architecture. And yeah, that's it, I guess. Like we started with a basic architecture, which where we have only one application server and one database server, and we scaled it. We introduced load balancer, we introduced horizontal scaling on application server, we introduced caching layer, we horizontally sharded our database server. So a lot of things we introduced in order to scale our system. And I don't say that it's a very correct approach and it will work for every system. It's a generalized approach, and depending upon the system, you can decide which way you need to go. But yeah, it's a generalized approach, and you can perform this in order to scale your system. Um, okay, so this is done. I'll probably discuss some interview tips for system design interviews if you want, and we can take up a few questions as well if we have.
Yeah, I think we do have questions both in Q&A and chat box. So please go through it, Saurav, and let us know what are the questions I've already answered. And there's some questions in the chat also. So please make sure of going through it.
Okay, Ankit asks, what does statefulness means? So Ankit, statefulness basically means that every application server can maintain some state of the system, like your your some data which is used very frequently, it can put that in the cache, and that is basically a state which is maintained by the application server for a particular request. And why the state is maintained is that if that request is coming multiple times to your application server, then it expects that it can use that state in order to fetch the data instead of fetching again and again through the database server. So that that basically statefulness means, and load balancer ensures that that statefulness is maintained in our system the way we discussed earlier. Okay, Tritha asked which system design book do you follow? Okay, I basically follow designing data intensive application. I guess I have this with me, so this is the book which I follow. You can also follow that. This I guess this is considered a Bible in system design. So it's a very nice book. It's a lot of wisdom there. So I basically follow this designing data intensive applications. And if you want, you can also buy one. Um, okay, how can we cache such a huge database if required? Abhishek, actually, we won't be caching the entire database because since the temporary storage has a limit and the storage limit is very small. So what cache does is that they have a policy, eviction policy, on which they decide that which data they need to keep in the cache and which data they need to remove. So basically most of the cache use LRU policy. It's a least recently used policy, and what it does is that the keys which are not in use or which are not in much demand, it eventually goes down, and as they go down they finally gets evicted from the cache. Once the cache storage has exceeds its limit, it starts evicting those keys which are in very less demand, and those keys which are in a huge demand, it always stays up. So what happens is that if you are demanding a key from the cache, then it will return that key to the return that value to you, and it will put that key value pair at the top. And in this way the key value pair which is in a very huge demand stays at the top, and those which are not in demand or not being asked for, they start going down, and after a few of some time they get selected. So that's why cache you can't rely on a caching layer only. Like there is a very few there is some chance that you can't get your data from the cache. You need to hit the database server. So yeah, it's based on the eviction policy and which keys are getting used. Could you please recommend cache database? Basically, there are multiple services which provides caching in AWS. I guess Memcache and Redis are most frequently used. Uh, they are caching services which are provided by AWS, and it is very similar. They are a key. You can store key value pair. You can read from it. You can write from it. You can write to it for a particular span of time. You can decide till what time you want to keep a particular key value pair in your cache storage. What if one cache? Okay, Ankit asks, what if one cache request fails? Okay, so if one cache request fails, then the application server will ideally hit the database server, get the data from the server, store that in the caching, and it will return it to the client. So that next time, if you want to request for the same data, you won't need to go to the database server again. So you can probably get that from the cache. Designing data intensive application book. Yeah, yes, Roshan. Designing data intensive applications. Yeah. Can there be any possibility of scaling the load balancer more? Like, yeah, I think you can have a pool of load balancer, and I think you can have one load balancer for balancing the load to that load balancer. It depends how you design your system. Like, anything can go. Can you give a small example of caching? Like, example of caching, like, and it's suppose there are multiple sites. Like, suppose there is a particular article on Medium or suppose Geeks for Geeks, which is in very high, huge demand. Everybody is reading it. So what we can do is that we can put that entire HTML article content into the cache so that the load on the server can be reduced. How to check cache? Okay, you can check your cache score. Actually, you can program it. um, Basic concept is that number of cache hit divided by total number of calls into 100. So that will give you the cache hit percentage, and you can probably see that what is the cache percentage. So if the cache percentage is 50%, 40%, or even 30%, then it's good. Like 30% of the data is served from cache. So you are saving some database call, and you are saving some money as well. Do database offer? I guess some databases have built-in cache, but still, since we are discussing about very naive application and servers, we will consider that the database server doesn't have an inbuilt cache, and we are introducing a caching layer to achieve that. Yeah, I guess. Can there be any possibility of scaling the load balancer more? Like, yeah, I answered that question. In payment. What other
We
resources?
also have questions in the Q&A tab, I guess. So please go
Yeah, there
further.
are. Okay, what are other resources? Okay, other Kishan asks, what are other resources do you recommend for system design apart from booking? Actually, I have one newsletter. Like I used to post articles on distributed systems and system design weekly on my newsletter. So if you visit my LinkedIn profile, there is a link on the featured section to my newsletter. You can simply subscribe to it as well. So weekly you can get article, and there is a nice collection of editions on distributed system concepts. Like you can get replicated systems, a database which are data structures which databases use to build their data storage and all. You can get multiple editions in the newsletter, which might be helpful. You can check that out probably. Okay. Yeah, so let's go ahead with tips for your interviews. Like, okay, there are some the system design interviews are very famous. Like if you have 2 to 3 years of experience and you are going for an SD2 role or SD3 role, then there is a huge chance that you will have one or two design rounds, one HLD round, one system design round probably. So these are the few tips which I also keep in mind. First is the communication. Communicate with your interviewer. Like communication is the key in any interview, even if it is a data structure algorithms interview or a system design interview. You should communicate with your interviewer as much as you can. You should spell out your ideas or what you are thinking out loud to your interviewer, so that he can know your thought process. He can know that what you are thinking and what you are capable of. Another thing which is most important for me, or the most important tip for me, is that I don't consider system design interviews much like an interview. Instead, you can consider them as a discussion. Like consider that it's not an interview. You will be having a discussion with your interviewer, where you along with your interviewer will be building a system. He'll be giving you some set of features which you need to implement. He will tell you about the load which your system need to handle, and you will gonna build that for that load. So that help in reducing the nervousness, I guess, and stress as well. Like if you are thinking it as a discussion, you will be quite cool, and will it will be okay, I guess. And the third one is always, yeah, always try to understand the problem and record. Yeah, that is the major thing. Like many times what we do is that when we get a problem statement, we jump into it. And instead, what should we do is that we need to understand the problem very clearly, understand what the problem demands, understand very clearly that what are the features, what are the set of features you need to implement. Since the interview will be about 45 minutes to 1 hour, right? And in that span of time, you can't implement the entire system. There will be a set of features which you need to implement. There can be 4 to 5 features which your interviewer will demand you to implement. So be clear about it. Ask your interviewer again and again. If you are confused about a feature, clarify that with your interviewer, that what does he need. And once you have outlined all the features, then you can go ahead solving the exact problem. And since suppose you have 4 to 5 features, then what can happen is that you can divide that into multiple sub problems. Like you can suppose you have 5 features which you need to implement for your system, so you can divide your entire problem into 5 sub problems, where in every sub problem you will be solving one feature. So this also works a lot. And try communicating time to time with your interviewer. And yeah, that's it. Apart from that, you can read engineering blogs and tech talks. Like there are some engineering blogs, like some of Facebook, Netflix, Google as well maintain their engineering blogs, where they post some of the technology breakthroughs and all, like what are the architecture they use sometimes. And they also mention that in their talk as well. So that is also a great source of wisdom and great source of knowledge if you are trying to be good in system design. I also follow all of these, and you might also do the same thing. And yeah, that's it. This is done. Like this is the only thank you, and basically all the best. If anyone is having their system design rounds coming up, you may ace the interview, I guess.
Some questions in the chat right now.
Abhishek asks, I guess, can microservices be useful in scaling a system? See, it depends upon your architecture, whether you are going with a microservice architecture or a monolithic architecture. Like they both have some advantage, they both have some drawbacks. So it typically depends upon your system. There are multiple software companies or multiple companies that follow microservice architecture, and it is going well for them. You can also follow hybrid approach as well. While some of the part of your system can be monolithic, some can be microservices. If okay, Krupesh asked if C1 send request to server 1, then it is cached after some time. If C1 again sends request but server 1 is overloaded, in that case C1 will have to wait, or load balancer will send the request to server 2. Ideally, if the wait time is not that much, then ideally it will wait. It will wait in the queue for one request to get processed, and when that is being processed, it will be sent to the same application server until the application server is down or has failed. Then the same client will mostly be sent to the same application server most of the times.
Sorry, we have one question from YouTube Live,
Oh, okay.
and it's Nishant, who asks, how can I design scalable system plus how can I improve the DSA part?
How can he improve the DSA part?
Yeah.
Okay, so it depends. Like, if you are practicing DSA for cracking interviews, then I think lead code will be fine. Like, practicing easy and medium level lead code questions will, I guess, will be fine. If you want, you can also go with the hard as well. But yeah, lead code is enough if you are practicing for interviews like Google, Facebook, like other fan companies or any other product-based company interview as well. You can go with lead code. And design scalable system, it's about practice. I think if you are working, then you will get some wisdom from there as well. And apart from that, you can read and watch tech talks and some talks where engineers describe that how they design their architecture and all. So read much as you can, explore multiple architecture, multiple possibilities, and yeah, you'll be fine.
And yeah, we have one more question, which says, how can I change to SDE1 role has backup?
How can we change?
SDE1 role has backup.
I don't get that question.
Yeah,
How,
even like,
okay.
uh, the name is not mentioned, but I think he should be more precise.
I think he wants to switch to SD1 backend, I guess.
Yeah, I guess. Yeah.
Uh, Apply for SD1 backend if you want to switch for it. Like, and then if you want to prepare for it, then go, well, practice data structure algorithms. And if you have some experience and you are expecting a system design round, then practice system design rounds as well. And yeah, you'll be fine. You can
Yeah.
apply for the roles and all. Yeah.
So guys, we might take up last minute questions. If you have anything that you quickly want to ask, please do mention us and please do ask us your questions so that Saurabh can take the questions at the last minute.
Padmbala says, I guess, please specify resources for knowing about system design algorithms like Bloom filters. Okay, for that, I guess I also need to explore. Like, there are some newsletter as well for multiple engineering. You can also simply Google it. You will get the resource. Like, it will be probably on Geeks or Geeks or somewhere. You can get it.
I think Abhishek has asked some questions in the Q&A tab. Did we miss
Okay.
any questions in the Q&A tab, Saurabh? Just please have a quick on
Uh,
that.
okay. Can microservice? Okay. He has asked one question. Can microservice be useful in scaling system? We have answered that, and I guess there are a lot of chats, so it will be hard for us to. Like, and there are okay. There are two, three Abhisheks. Okay, no, there are only one Abhishek. Let me see. Yes. How can
If
I?
there's any question unanswered in Q&A which you think might be useful for the audience, please take that up. And if there's something that's been already covered or answered, I think we can just go ahead.
Okay. How to check cache's effectiveness? Okay, that has been answered. Um, I think most of the questions have been answered, Hafsa. Programming language is a very big factor. We have answered that. Since we are using high level design, programming language doesn't matter much. Mm, yeah. Caleb has said he has a question. Caleb, if you have a question, you can post it here. I'll answer it. Or Caleb is also connected with me on LinkedIn as well. You can DM me anytime. We used to talk.
Yeah, I will give the link of Saurav's LinkedIn profile in the chat so that you can connect and you
Yeah.
can ask questions to him specifically. Yeah, we have one question which is,
We can use both L4 and L7 load balancer. Yeah, like even inside a system, if that system is very huge, you can use 2 to 3 types of load balancers depending upon the requests coming. It is possible, but still you need to be you need to take care of a lot of things if you are using L4 and L7 load balancer together, because it might send the same request to different servers. Like if that request comes to the L4 load balancer, it can send it to a different application server. It might, and if that same request comes to L7 load balancer, it might send it to a different application server, because they both use different logic or different layers to decide which application server they should send the request to. In payment system, how do cash prevent double payment? Okay, I need to look at it, like which payment system you're talking about, Caleb. We can have a discussion about this, detailed discussion on LinkedIn maybe. There any resources to learn about caching and load balancing? Yeah, there are a lot of resources. You can go on my newsletter as well. I have editions on caching and load balancer where I have discussed statefulness and all. You can probably have a look at that as well.
okay, I think all the questions are covered, and that brings us to the end of this session. I hope all the questions are covered and no one has any questions further. If you have, I'll drop the link of Saurav's LinkedIn in the chat so that you can just connect with him and discuss more about some topics that you want to have elaborately explained. Okay, we have one more question from Abhishek. How auto scaling and managed apps help in system design and caching?
How auto scaling and managed apps help in system design cache? Okay, auto scaling. So auto scaling is basically, if I guess this is the service which is also provided by AWS as well. When a particular, so it basically increases the number of instances on the basis of increasing load. So what it does is that it saves your money and saves the computation, the resources which you are using, because suppose at some time you have a very less amount of load, it will fire only 1 to 2 instances. And suppose at a particular point of time the load on your system increases, then it can fire more instances, and so in order to handle that load, and if that peak again goes low, it can pull off some instances, and it can also reduce. So it basically maintains the number of instances so that the uh, computation is used efficiently, the resources is used efficiently, you are not spending too much of your money on unused resources. So yeah, that is, I think, the concept of auto scaling basically. How to code load balancer? Okay. this is a, this is a very detailed question. Like I guess we can have a separate webinar for that, like how to code a
Yeah,
load.
we will definitely bring Saurabh for that so that we can have a
Yeah,
detailed session on that. So please let us know how many of you want a detailed session on how to code balancer. And we'll definitely bring Saurabh
sure.
to some another webinar of yeah. Okay, we have one more chat.
Is sharding reflected across multiple servers in a replicated replication setup? I need more context on this question, Abhishek. Actually, like, are you talking about database sharding, and what is the situation here? Like reflected across multiple servers, which server, application server or database server? Uh, yeah, like I need more context on this. DB sharding, DB server. Okay, so if you are sharding a database, it will be reflected on each and every application server, because all of them need to have the data. So if you are introducing one extra shard or removing another shard, you need to let every application server know that we have changed the configuration or changed the distribution of the data, because it's not guaranteed that which application server can demand for what kind of data. So ideally, it will be a good idea to um, basically contact with every application server and let them know that we have changed the configuration. Okay. Is there any community where we can give mock system design interviews? Do Recro have anything like that where people can
For
give
mock
mock?
system design interviews, we do not, but we do have a community that We are doing it on Discord, and that is for React and JavaScript developers right now, which is going to be closed community. But if we do have something around the mock system designs, we will let you know. You can check out the Recro's page if you want any updates on the community aspect of it.
Yeah, right.
Okay, so I think that was the last question, and that brings us to this end of this wonderful session. And I would like to thank each one of you for joining us. Hope you learned something new from this today's session. We will look forward for your post on LinkedIn along with your key learnings. Don't forget to tag Recro, tag Saurabh, tag me. And thank you for being such a lovely audience and being so interactive and engaging for all the time. And also, thank you so much, Saurabh. It was great having you, and it was awesome for the for really like had a great and wonderful session with you. Thank you for taking out time and sharing such insightful
Sure.
information.
Thanks for having me. Really nice.
Yeah, so before we end the session, there are a few announcements that I want to make. So we have created a community for developers called Recro Tech Circle, where you can connect with fellow developers, get career opportunities, and ask for help. The link of the community will be dropped in the chat, so you can just like make sure of joining it quickly and go say hi to the other fellow developers if you have any questions regarding any topic or any framework or project that you're working on. Feel free to ask and feel free to contribute your learnings and experience with it. So we have made a LinkedIn post about the session. Do comment your learnings in the post. The link of the post will be dropped in the chat right now. And I hope most of the questions were already answered by Saurabh, and there were a lot of questions being flooding even at the end moment. So I think you had really great time listening to the presentation and what the experiences and the knowledge that Saurabh brought in today in this webinar. And if you have more questions regarding anything, you can connect and follow Saurabh on LinkedIn. So I'll be dropping his link in the chat box. You can connect and he'll be more than happy to connect with you personally and answer your questions or, you know, discuss any queries that you are actually facing right now. If you're exploring career opportunities, Recro is hiring passionate developers. Check out the current openings at Recro, or maybe you can refer some friend or colleague you think might be appropriate for it, and we'll make sure of placing you at the high growth and A-grade startups of the country. To stay updated with such events, you can follow us on social media, and the recording of this webinar will be on our YouTube channel, Recro's YouTube channel. You can just go check out the live recording, and we also put out the edited version of this webinar. So you can just go, and if you missed any at any point of this webinar, you can just go and have a relook and maybe share with your friends or colleagues who you think might take an advantage out of this webinar. So that's all for this session, guys. Thank you so much for joining us. Hope to see you in the next session. Take care, stay safe. Thank you so much. Thank you so much, Saurabh.
Thank you. Thank you.